Scientists may have been searching for aliens in the wrong radio frequencies. For decades, humanity has searched the skies for evidence of intelligent extraterrestrial life by listening for unusual radio signals. But what if we have been searching in the wrong part of the radio spectrum? New research presented by astronomers at the Royal Astronomical Society suggests that potentially important frequencies have received remarkably little attention. Researchers used archived observations from the powerful ALMA telescope in Chile to conduct its first SETI survey at much higher radio frequencies. The search found no candidate alien signals, but it revealed something fascinating. Even a handful of telescope observations can contain information from millions of stars that astronomers never originally intended to study. Most radio SETI, or the search for extraterrestrial intelligence, has traditionally focused on frequencies between about 142 and 166 GHz. This region is often called the cosmic water hole because it lies between natural radio emissions associated with hydrogen and hydroxyl. Since these elements are fundamental to water, scientists have suggested that an advanced civilization might recognize this region as a logical place for interstellar communication. But the electromagnetic spectrum is enormous, and large portions of it remain almost completely unexplored for signs of intelligent technology. That is where this new study becomes particularly interesting. Louisa Mason, a PhD researcher at the University of Manchester, examined archived observations from ALMA, the Atacama Large Millimeter Submillimeter Array in Chile. ALMA normally studies objects such as distant galaxies, stars, planets, and the cold material between them. Mason instead searched existing observations for extremely narrow radio signals that could potentially indicate artificial technology. Rather than collecting new data, she revisited observations originally made for completely different scientific purposes. Her work represents ALMA's first SETI survey. The search examined two narrow frequency ranges within ALMA's band, 3 observations. No candidate technosignatures were detected above the survey's detection thresholds. But that does not mean the experiment was unsuccessful. In fact, the researchers believe the result demonstrates that millimeter and submillimeter wavelengths could open a completely new region of SETI research. These higher frequencies have been largely overlooked compared with the traditional radio bands. An advanced civilization could theoretically use communication technologies operating in these ranges, yet humanity has barely begun systematically searching them. The study also uncovered another surprising feature of astronomical observations: stellar bycatch. When a telescope points at a particular astronomical target, its field of view can contain many additional stars surrounding that target. These stars aren't the original subjects of the observation, but their signals can still be captured. Traditionally, astronomers estimate this hidden population using catalogues such as Gaia Dia. But catalogues cannot always identify extremely faint, distant, or otherwise difficult to detect stars. To solve this problem, Mason used the Besançon galactic model, a simulation that estimates how stars are distributed throughout the Milky Way. When researchers applied the model to an earlier SETI survey containing 1327 telescope pointings, Gaia data indicated that approximately 288,000 stars were included. But the galactic model suggested that the actual number could exceed 6. 1 million stars? That's a dramatic difference, and it means astronomers may have already examined signals from millions of stars without realizing how many stellar systems were actually present in their observations. This discovery could have major implications for the future of SETI. Astronomers don't necessarily need to build a new telescope every time they want to investigate a new scientific question. Vast archives of astronomical observations, AL, already exist, containing information collected for countless different purposes. As artificial intelligence and advanced data analysis techniques improve, researchers can revisit these archives and search for patterns that earlier scientists were unable to detect or weren't looking for. Imagine a telescope observation originally designed to study a distant galaxy. Hidden inside that same dataset could be signals from stars between Earth and the galaxy. A survey designed to study star formation could potentially contain information about objects never considered relevant to the original project. The same data can therefore become scientifically valuable in completely new ways decades after it was collected. However, the researchers emphasized that the absence of a signal should not be interpreted as evidence that intelligent life doesn't exist elsewhere. This particular study examined only 4 archived observations and 2 limited frequency ranges. That's an incredibly small portion of the sky and an even smaller fraction of the electromagnetic spectrum. An extraterrestrial civilization could be transmitting at another frequency, communicating intermittently, using technology we don't recognize, or simply be too distant for current instruments to detect. The real message from this research is therefore not that scientists found aliens, but that we may have been searching only a tiny fraction of the places where alien technology could reveal itself. Future SETI projects could expand into higher frequency radio bands while making greater use of existing telescope archives. Combining broader frequency coverage with improved simulations and artificial intelligence could allow astronomers to examine millions of additional stars. For now, there is no confirmed extraterrestrial transmission from ALMA. But the search for intelligent life is ultimately a numbers game. The more stars we examine, the more frequencies we explore, and the better our detection methods become, the greater our chances of recognizing something truly extraordinary. Humanity may have spent decades listening to the universe through a very narrow window. Now, scientists are beginning to open that window wider. And perhaps the most exciting possibility is that the next great SETI discovery isn't hiding in some distant, unexplored corner of the cosmos. It could already be sitting inside astronomical data we've collected, waiting for someone to finally know where to look.